Okay, so this is section 2.4, and I'm going to work through as many of these problems as I can fit on the videos for the homework in case you're struggling, okay? So number 9 is the absolute value of 2t plus 5 is less than 3. Now when we have the absolute value is less than something, what this ends up being what we call a sandwich inequality. That's what I've seen it termed that before. It's not really my term, but that's what I like to call them as well. And what that means is we take the term that's in the absolute value, the 2t plus 5, and it is, we're going to write it down the way we see it. It is less than 3, but it's also at the same time bigger than negative 3. So whenever you see that less than sign, remember it ends up being one of these sandwich types. And then in order to solve this, all you got to do is get t by itself. So you could subtract 5, but you got to do it everywhere. Okay? So once you do that, you get negative 3 minus 5, or negative 3 plus minus 5. It's the same thing. Is negative 8 is less than 2t is less than 3 minus 5 is negative 2. Okay, now we got to get t by itself. Okay, to get t by itself, it's multiplied by 2. The opposite of multiplying by 2 is dividing by 2, so everybody gets divided by 2. And we end up with negative 4 is less than t is less than negative 1. And you've got to graph this. So you're saying, okay, this number t, whatever it is, it can be a lot of things, but anything in between negative 4 and negative 1 is going to work. There was no line under the inequality, so these are my boundary values. I'm just going to circle them and not color in the dots because we don't count negative 4 and negative 1 since there wasn't a line under each of those inequalities. And then we just shade, because t is between them, we just would shade in between, and that represents all the numbers that would work. Okay, especially try to do the evens since I signed them and they're not, you can't check them, but if you want to check them, you could at least be watching the video if you wanted to see if you did it right. 3x plus 2 is greater than 4. Okay, so this is a greater than. So if you remember with a greater than ones, it splits up into two inequalities. And one of them, you copy down what you see without the inequalities, without the absolute value sign. So we have 3x plus 2 greater than 4. But then we say also it could be that 3x plus 2 is less than negative 4. So on this one is the tricky one. You reverse the inequality sign and you put the negative of that 4 there. Because what we're saying is the distance is greater than 4 units away from some number. And so it could go in the positive direction or it could go in the negative direction. So we could look at going 4 to the right, which is this left-hand one right here. Or we could look at going at 4 to the left, which this is what this one represents. All right, so we've got to solve each one of these. Be careful. These don't come out to be the same numbers usually, and a lot of people just think it's going to be plus or minus the same thing, and it doesn't work out that way. If I want to get x by itself, I need to subtract 2 over here, and so what I'll have is 3x is greater than 2, and if I'm getting x by itself now, all I got to do is divide both sides by 3. I got 1x is greater than 2/3. Okay, over here I'm going to do the same steps, but you got to be careful. I am going to subtract 2 just like we did over there. Let me put it in red since that's what I used on the other side. Okay, and I do have 3x is less than, but what's negative 4 minus 2 or negative 4 plus negative 2? It is negative 6. You notice this is not going to be the same number on both of these inequalities. I want to get x by itself, so I'm going to divide the 3 off both sides. And I'm going to get x is less than negative 2. It is not plus or minus 2/3 or plus or minus 2, and that's what the mistake that a lot of people make on these problems. They just think, oh, I got a 2/3 here, it's plus or minus 2/3. No, the negative kind of messed that up for us. All right, so my boundary values are negative 2 and then 2/3. So you could show it this way. You remember when we have a boundary value, we circle it. X is greater than 2/3. Let me kind of color code these. I'm going to do this one right here in blue. X is greater than 2/3 goes this way. Or, I'll do the other one in green. X is less than negative 2. That's out to the left of this value. So we could have numbers that would work in here would be where any of this shading would be. Negative 2 would not work. 2/3 would not work and make a true statement. But anything bigger than 2/3 or less than -2 would work. All right, for number 11, we have the absolute value of 2u minus 5 is equal to 0. If you remember when we had equal signs, we would put like the part that's in the absolute value sign, 2u plus 5, is equal to whatever the number was out here. But then we would actually have to go put it's also equal to the negative of the number that is sitting right here, okay? Well, the problem is there isn't a positive or negative 0. So in this case, we're only going to have one answer because you can't say plus 0 and minus 0 and get a different number. So we just need to solve for u. We add 5 to both sides, and we get 2u equal 5. And then to get u by itself, we just divide both sides by 2, and we get our answer, and it's just one answer. U is equal to 5/2. And then number 12, which again we will make sure we do because it's an even one, and I know you can't check it in the back of the book. Notice in this assignment they're mixing up equals and greater than and less than just to see if you got the hang of it. They kind of took some time a little earlier with some things separately, but now they're just mixing it together. We have 8 equal 5y plus 2. If it bothers you to look at that right there, do you realize you can always rewrite something? If it's an equal sign, you can just switch the two sides, and that might make it look more like your brain's used to seeing it, okay? So when we have an equal sign, if you remember, you take whatever's in the inequality inside the absolute value brackets. Too many special words in this lesson, aren't there? We take the 5y plus 2 and we set it equal to positive 8, and then we come over here and we can say we take it and also set it equal to negative 8 because it's telling me the distance is 8 units away. It might be 8 units to the right, which would be represented by the positive 8, or it might be 8 units to the left, represented by the negative 8. Okay, so let's solve each one of these, and again, we got to be careful. We can't make an assumption that everything's always going to be a plus or minus the same number when we solve. If I want to get y by itself here, I will subtract 2 from both sides, and I will get 5y is equal to 6. And then if I want to get y by itself, I just need to divide both sides by 5, and I get y equal to 6/5. Okay? But there's also another answer. So we're going to go over to the right-handed one now. If I want to get this y by itself, I'll subtract 2. And negative 8 plus negative 2, or negative 8 minus 2, remember that's the same thing, it's going to be negative 10 on this the right-hand side of that. And so I've got 5y is equal to negative 10. Now if I want to get y by itself, I'll just divide the 5 out of both sides, and I'll get y equal negative 2. So let's draw our number line and graph this. I may have forgotten to do that on the last problem, but so we got two answers. We've got 6/5 and we got negative 2. If we represent them on the number line, let me draw. We don't have, these are not inequalities, so there's not really shading to go on here. These are just the two answers if we're asked to graph it. So we got an answer at negative 2, so we'll shade that dot in. And we got an answer at 6/5, we'll shade that dot in, and those are all the answers. There's not any shading on the line to do because it's just equal to those two numbers. I'm going to go ahead and try to get in as many of the others as I can on this one video. Number 19, x plus 5 minus 3 equal 1. Okay, in order to even start to think about this, I need to get that absolute value by itself on one side. So you need to get the absolute value isolated. Get it on one side by itself. That's what you're going to have to do with all these down here in the second part of this lesson in the B section. Is you're going to have to do that. Okay, so let me go ahead and say to get the absolute value by itself, I'll add 3 to both sides to get it where it's all by itself. We always do the opposite, right? So that gives me the absolute value of x plus 5 equal 1 plus 3 is 4. Well, now when we get it to this point, it's just like all the ones that were in the section above. If I've got an absolute value equal 4, that means the distance away from some point is 4. Okay, so I'll take the x plus 5 that's inside, and I can say, well, it's either 4x plus 5 is 4 units away from some point, or x plus 5 is 4 to the left, and we represent 4 to the left with a negative 4. Okay, so now we just need to get x by itself on both sides. If I subtract 5 from both sides here, I get x is negative 1. And if I subtract 5 from both sides over here, I'm going to get x is negative 9. And since it tells us to graph the solution set, no, it just tells us to solve on 19. So if I wrote my list of answers, I could write x equal negative 1, x equal negative 9. But the way the book likes to do it is to list them. You always put the smallest number first when you're making a list. And then just kind of keep gradually going up. Here would be my answer. Okay, so now we're going to look at 21. 21 says the absolute value of 2u minus 1 plus 3 is less than or equal to 6. Just like the last problem, I need to isolate the absolute value before I can really break it up. So I can't really even start on it until I get that absolute value on one side by itself. Well, the easiest way to do that is going to be just to subtract this 3 from both sides. Okay, so what I have now is absolute value of 2u minus 1 is less than or equal to, well, the 3's cancel out, 3 and the minus 3 cancel out, and 6 minus 3 is 3. All right, since the absolute value is less than 3, the distance, some distance that we're talking about with this expression is less than or equal to 3. If you remember on these, you just take what's inside the inequality and you sandwich it in between the positive and negative number that's right here, okay? So then we just solve for the variable u, okay? Well, the first thing we do when we solve is we add or subtract anything, and we're focusing on where that variable is right here. We're not really looking at any, we're saying, where's the variable? Oh, here it is, okay? So that's where we're going to work. To get the u by itself, I'm going to add 1. I'm going to do the opposite of a minus 1. We always add or subtract first. So negative 3 plus 1 is a negative 2. And then 2, we'd be left with a 2u when the minus 1 and the plus 1 add to 0. And then we have 3 plus 1 is 4. Okay, now I got to get u by itself. Well, it's got a 2 multiplied by it, so what I'm going to do to get rid of it is divide everything by 2. And negative 2 over 2 is negative 1. These make a 1u. And 4 divided by 2 is 2. And so there's my solution set. They didn't say I had to graph it, so we won't graph it in this case. But there we go. We'll try to fit 23 in. 7 minus 3 times the absolute value of 4d minus 7 is greater than or equal to 4. All right, I want to get the absolute value by itself. Okay, so first thing I'm going to do is add or subtract. And I've got this 7 here. I could subtract from both sides and move it over. Okay. So that gives me negative 3 times the absolute value of 4d minus 7 is greater than or equal to 4 minus 7 is negative 3. Okay, I still want the absolute value by itself, and it's not quite there yet. It's multiplied by negative 3. So the opposite of multiplying by negative 3 would be dividing by negative 3. Well, that cancels out over here and makes one of these absolute value of 4d minus 7. And then negative 3 divided by negative 3 is 1. But here's the problem. I just divided by negative, right? So what I have to do, the minute I did it, I need to switch the direction of the inequality sign. So it gets switched when we divide or multiply by negative and reversed. All right, so now I've got 4d minus 7 less than or equal to 1. If you remember, when you have this less than sign that's going on right here, that means we're going to sandwich that expression. We're going to take the thing in the absolute value, and we're going to sandwich it in between a positive 1 and a negative 1, the number that was over here on the right. And I'm going to kind of quickly go through this because I can tell I'm running out of time. To get the d by itself, I'll add 7 first to every part of this inequality. And negative 1 and 7 is 6. And we'll have a 4d here. And 1 plus 7 is 8. Now to get the d by itself, I need to divide everybody by 4. Okay, so now 6 over 4, that reduces to 3 halves. And then you got your d, because these 4's cancel out, and then 8 divided by 4 is 2. And that would be my answer there.